Hi everyone, welcome back to the workshop. So today we're going to do a little bit of a tutorial. Something I keep seeing come up over and over and over again in the groups and on the Facebook pages is soldering. What is the right way to do it and how do I go about doing it? So I'm going to show you how I do it. This is not a you must do it this way, but it's definitely going to be a little bit of an eye-opener for some of you who've never tried it or you struggle with it. So hopefully a few of the tips and tricks that I'm going to show you are going to help you do successful soldering and you won't be reliant on everybody else to do it for you. So if you watch one of my recent videos that I will post at the end of this one, I did a few repairs. I did a servo repair and I did a motor repair, and on both of those they involved a lot of soldering and some of it was very intricate. Now I get that not everybody's going to be able to do that, but maybe after this video you're going to be a lot more confident in trying to do that yourself. And I wouldn't say, you know, with very expensive items go straight into it, but certainly if you build up to it, it's something that you could do and you're going to save yourself loads of money in the long run. So in the video we'll look at a few key things. So one of them is, what is the equipment that you need to be able to do it? We're going to look at a few examples. So I'm going to solder a motor, which is something that all of us have either done or we need to do at some point. I'm going to do a repair on a servo wire. We're going to look at what we call tinning, which is getting the solder onto the wire, and also do some desoldering using some solder wick. Now, I have one other tool in my arsenal, which is called a solder sucker. Now this can be really helpful if you end up putting too much solder onto a joint and it gets really messy. So we'll have a look at what the solder sucker does. It's fairly self-explanatory, and how you can use it. So let's get over to the bench, have a look at the items that we're going to be working with. I'll go through and I'll explain what each one of them is for, and then we'll get into soldering. So what do we need to be able to solder? So first of all, obviously we need a soldering iron. This is a quite an industrial type one with a fine tip on it. I've used this for donkey's years. It's been absolutely fantastic. It's auto sensing as well, so it detects that whatever you're soldering is drawing a lot of heat away from the tip, and then it builds up the temperature back quickly. So that's quite helpful. We've got the stand here, so it saves me holding all the time because obviously it's hot. It does have a sponge incorporated into this as well, which is used for cleaning the tip, and that's important because you get a lot of corrosion and debris that builds up on the tip, and obviously that can put impurities into your solder, into your joint, and it can make it a bad joint. We've got a tube of flux. This is nothing special, it's just soldering flux from Amazon. You might use this for probably more desoldering than soldering, to be honest. The solder that I do use does have flux built into it as well, so that for me is quite an important thing because I don't like the faffing around of having to put this on every joint, and then obviously you've got to clean it off afterwards as well. So we've got a few test pieces. I've got a bit of just blank printed circuit board here. It's copper on the top, fiberglass on the back, and this is the sort of thing that you might see in your hobby. So we'll just do a couple of little solder joints on that. We've got the solder wick. So this is like a braided copper. The idea of this is that when if you do a solder joint and you want to get the solder off, then you can put this on, put some heat onto it with a soldering iron, and as it says solder wick, the solder will wick up into it and it will remove it from the piece that you're doing. We've got a couple of motors. So we've got a 180 size from like a 18th scale crawler here, and then I've got a 540 size motor, which most of you will recognise from sort of a Tamiya size kit. Got a good selection of heat shrink in here. Generally use red and black because obviously DC voltage, you generally positive and negative. I've got an old servo wire here, which is what we're going to do a repair on. I've got an LED, which has got some really thin wires here as well. So I thought we'd do a little job on that one. A couple of bits of 14 gauge wire. This is the sort of size that you generally see on a motor. We've got a couple of little bits of heat shrink here to go onto a plug. So I've got an XT60 here, which again, you know, sort of thing that we're going to be doing quite a lot of. And then just here, I've got a couple of examples of little tools that are useful when doing this. So for years and years and years, I've used a humble clothes peg, obviously a wooden one, so it doesn't catch fire every time you use it. But it's surprising how versatile a clothes peg can be. And if you were to get like a little board with of wood or something like that, and you can hot glue a couple of pegs onto it, you can make quite a handy holding tool. This is one I just 3D printed off the internet. I think this would do the job. I don't think it's going to be the best. I think the best will be the one that I'll go to in a moment. But it's just got some grooves cut into it, and the idea is that you wedge the wire in it, and then obviously it's like a third hand really. So you could do, you know, if you were doing a soldered joint and you wanted to put one either side, you could do that and then solder in the middle, and then obviously you're not going to burn your fingers. But I have to say, this is my favourite, and this is a design that I found on Thingiverse, and it's just a couple of almost like crocodile clips really, but it's really neat, really simple, just a couple of elastic bands. And the idea is that in the jaws you can just hold the wires in the jaws like this, and then that frees up your hands, you know, one for your solder, one for your soldering iron. So we'll have a go at using that as well, and then we can judge that at the end. But like I say, for many years I just used like a humble clothes peg. It's always been a really helpful tool. You just hold it in, you know, you could put a bit of weight on it or something, but again, it's just like a third hand, and it saves you burning your fingers. So let's get the iron fired up, get it up to temperature, and then we can start having a look at, we'll probably have a look at the big motor first, because that's the sort of thing that's going to be used like example wise for the most of us. So I think we'll have a look at this 540 size can motor first, because that's going to be the sort of thing that most of us are going to do on a regular basis. So this is my solder sucker. I explained it a little bit earlier in the video, and all it is just basically like a spring-loaded plunger. And the idea is that you heat up your solder, and if you've got too much solder on a spot, you just heat it up until it's molten, put the tip in, press the button, and it literally sucks it away from the job. And this is really handy, like if you've got a printed circuit board, for instance, and you're trying to get the wire to go through the board, you can have loads of attempts at it, but you know, if you use a combination of the solder sucker and the solder wick, and you can clean the job right up before you've even started. So I just wanted to show you a couple of designs that I've done. These are my solder dispensers. So I've got two different size solder. I've got the small stuff for obviously little intricate jobs, and I've got the thicker stuff for bigger jobs. I'd probably say it's like 1 mil and 0.5 mil, something like that. But these are just handy little dispensers that I've 3D printed up. It's my own design as well. So it's just got a pin that goes through the centre of the reel, and then obviously this is just like a bit like a winch hose really. But that means it's nice and easily accessible for me. If I'm doing a job, I can just roll off a bit of solder and cut it off like that. So this first job, we're going to desolder the motor wires from this 540 can motor. Now obviously this is rocking backwards and forwards, which can be a bit of a pain. So we're just going to bring one of the tools in, and I'm just going to see if we can't wedge it on there somehow. There we go. So that's like using it like a pair of hands, and that's just going to hold that motor steady whilst I desolder. And what we do, we'll clean the tip of our soldering iron. So I try and keep things in shot as best I can. So we'll just clean off the tip of our soldering iron, and then just one little tip. So when you're soldering, it's a little bit like when you're cooking in a frying pan. If you cook something without any oil in the pan, it can take a long time for the heat to sort of transfer from the pan to the meat. So you put a little bit of oil in, and it helps with the transfer. So that's a little bit like soldering. So all I'm going to do is just put the tiniest bit of solder on the end, and then when you put it onto your job, it helps to transfer the heat from the solder, so the solder that you've got on your tip, to the new solder that's on, in this case, on the motor. And then we go. So we've desoldered our first wire. So what we'll do, we'll take these off, we'll cut them back, we'll tin them up, which is what I explained earlier, and then we'll have a go at putting them back on. So again, back onto the other wire there. Use the tip. So the tip is the hottest part, and then we go, we've desoldered those two wires. So once we've desoldered, I just want to clean that dirty solder off of the tip, put the iron back in the holder. Okay, so I'm just going to demonstrate loading up one of these with solder, one of these terminals, and then I can show you that solder sucker. So I'm just going to load this up with way too much solder. So hopefully there you can see on that terminal there's way too much solder on there now. Just set up one of my table clamps to hold on to that. So I'm going to show you the solder sucker. So I'm just going to load up these terminals with solder, just so I can show you the solder sucker. So here it is. I've depressed it. So all we need to do is, when we're ready, just press this button here. So I'll warm up the terminal, make sure the solder is all flowing. put the sucker on, and if you need to do it again, just repeat. And there we have it, nice clean terminal, ready to start afresh. Another great bit of kit for the soldering arsenal. There's loads of different types out there. They all look very, very similar. But at the end of the day, it's just like a plunger. All you need to do is occasionally just take the tip off and then just clean it out, because the solder builds up inside, and that's it. That's the solder sucker. So we're going to pre-tin our terminals. Don't need to go mad. And then simply hold the soldering on the back, wait for the heat to transfer through, and just hold it until it goes off. Then the same again. And that's it, simple as that. And that's the advantage of pre-tinning, is that you don't need to be messing around trying to feed in solder as well as hold the iron, etc. We got nicely soldered terminals on our motor. So that's the motor done. Move on to the next one. Okay, so that's the motor done. So let's move on to having a go at repairing one of these servo wires. Now this is definitely something we've all had to do. We've either cut through it, it's chafed or pulled or something like that. And as you can see, these are very small wires, standard servo wires. So what I'm going to do, I'm going to strip them back, and then we'll go through the process of tinning them, and then we'll put a bit of heat shrink on, and then we'll solder them up and do the heat shrinking. And that'll be a nice clean tidy joint, and hopefully save you loads of money from buying a new servo. Now what I like to do is I'll hold on to the braids, and then I'll give the outer sheath of the wire a spin, and it just brings all of the braids together of the wires. So you don't have to do that, but I just find it helps, and it saves you having stray braids on your wires. Okay, so hopefully you can see both of these. I'm going to give both of these tools a go just to see which one's best. So I've just wedged the wires in, and obviously this one clamps on. So again, clean the soldering iron, tiny amount of solder on there, and then we'll just touch on the wire. And when it goes well, it should just wick up. And this is one of the advantages of having the flux in the solder itself. And you do pay a little bit more, but in my opinion, it's definitely worth it. So you can see how quickly that's warming up, because it's a thin wire, and then we'll just warm it up a bit. And again, if you get too much solder on, you can just flick it off. Basically, if it flicks off, you've got too much on the iron. And then we'll just feed in a tiny bit, just get those wires pre-tinned like that. And again, 6 wires, what's that taking? Less than a minute. So it really shouldn't take you very long at all. So then we'll get some heat shrink. You want to pick one that's not too oversized. Most heat shrink will shrink 3 times smaller than how it starts, or at least twice as much. And again, don't be stingy. Cut yourself a decent amount for each joint. So I've probably cut 20mm for each one there. I'm going to use black for all of them just because the wires are coloured, so it's not really going to matter too much. So then what we do is we put the solder over each of the wires. Just take that out of there. So then what I'm going to do this time is, because again we've pre-tinned everything, so we don't need to add loads more solder. So I'm just going to clean the tip once more, just get any impurities off of that. Little bit of solder on there just to help transfer the heat. I'm going to hold the heat shrink back out of the way, and then if you get the 2 wires very close to each other, touching with the soldering iron, and then just give it enough time to go off. And as you can see, I'm not speeding this up, I'm literally just touching the soldering iron on, and they're soldering up. So I'm just gonna relocate that white wire because I need to hold it better. And again, that's what's nice about this tool, is it's holding it nice and steady. And I could even stick that down, or you know, even use, got one of my clamps here, so I could just clamp that, and now that's not going to go anywhere. And then just get that third wire, a bit more awkward because of holding it in the right place, but just touch that on there, and there we go. We've got 3 nice solid joints, and they are not going to come undone. So heat shrink, some people tend to use the end of the iron. I don't like that. I don't like to introduce like heat directly to it, as in touching it. So I either like to use my hot air gun, or I will use a lighter, which is probably the oldest method. So we'll just hold those in there a second. I'll get a lighter. Just got a disposable lighter. No, my luck's probably the only one with no gas in it. No. So there we go. And then just hold them apart between you. Make sure your heat shrink is centralised on your joints. And then rather than use the tip of the orange part of the flame, use the base of the flame a bit more, like the blue part, and then you don't tend to get burning. And then just move them around. And there we go. So hopefully you can see that. So it's a nice, strong, and that's pretty waterproof as well, joint to repair a servo wire. And again, you know, like in my last video, you could save yourself loads of money by just repairing a wire. You might want to extend it as well. I've done that before. Obviously, sometimes you want to put a receiver in a different place. So if you want to extend the wires on a servo, this is exactly the same method to do so. And that joint is going to be as strong, if not stronger, than the original wire. So there we go. So that's repairing a servo wire. Right, so another one we're always doing is fitting new plugs onto either our motors or whatever. So I've got this pre-used XT60 connector. So what I'm going to do, I'm going to desolder all what's in there. I'll re-tin it. We'll tin the motor wires, or ESC wires in this case, which is a heavier gauge, and then we'll get this soldered up. So again, our holder's going to come in useful. So I just put that in the clamp. Now, if anybody's interested in this, it's not my design. I think I got it from Thingiverse, but if I can find it again, I'll put a link in the description for you. So we'll be using the solder sucker again on this one. So again, clean the tip, a little bit of solder on there. Just going to use that to help transfer that heat over. We're going to melt any solder that's still in that terminal, and then we'll use the solder sucker to suck it out. So do everything you need to do, and you can see how much solder we pulled out of that. Look, all of that was in there. So you can see why it took quite a while to warm it up. So I'm just gonna get it heated up a little bit. Get in there again with the iron, with the sucker, sorry, and just suck out what's left in there. And then same again for the other terminal. We'll just, and you can hear the impurities popping in there. It's probably all sorts of dirt and grime in there. Try not to melt my soldering iron wire. So again, we'll just heat it up. Come in with the solder sucker. And obviously, if you're not reusing the terminals, then you won't need to do this. But I just wanted to do as much soldering as I could in the video to give you examples. You know, if you guys have got any examples of solder jobs that you struggle with, then let me know and I'll try and do a short on it or something, or try and give you a bit of advice. Because it shouldn't be daunting. You know, it's all part of the hobby. I like the fact that I'm quite self-sufficient, so I've taught myself to solder and things, and I get that not everybody's got the equipment and the skills and the space, but you know, hopefully this little video is just going to help you out a little bit. So what we'll do now, we'll strip back a couple of wires which are AWG 14, which is generally what you're going to get on a speed controller or a motor. Don't ask me what AWG is because I can't remember, but if you remember, then let me know in the comments. So again, we'll just put our wires in here like this, clean the tip, and again, when you the bigger the wire, the more important it is that you put that little bit of tinning solder on there, because that's a lot of heat that you've got to put on there. And the nature of silicone coated wire is that the silicone actually helps to absorb some of the heat. So sometimes as quick as you're introducing the heat, it's taking it away. So I'm just going to rub the soldering iron back and forth just a little bit, and I can start to see that starting to wick already. And again, every piece of solder that you add in, you're also adding flux, which is going to help keep that to flow, and the flux will clean away the impurities from the copper. So if you can hold the soldering iron on the back and then touch it on the top and the solder melts, that's the right temperature. So we'll do the same again on the black wire. So we're just a little bit of solder on the tip, backwards and forwards, get our soldering iron underneath, and then we just brush the solder along the top, and then once it's hot enough, I can just see that solder starting to melt there. Then we'll introduce a little bit more, and there we go, we get that tinned up. Just that one straggler there. Okay, so we got the tinned wires, so I'm just going to clean the soldering iron again, and hopefully you're starting to see a bit of a theme now. So clean the soldering iron, tin the soldering iron, put the heat onto the job, introduce the solder, and it should flow by itself. So there we go, we've got those two done. So we'll take them out. Just going to have a look on here. Usually the flat side of the plug is positive, so we'll just hold those in there like that in the jaws. Just going to get myself a little bit more solder. So we'll just get a little bit of solder on the end, pre-tin just a little bit, and then we got our red wire this side. So we just put the soldering iron onto the cable just to introduce some of the heat, and then we'll transfer it over to the terminal. And like I said, this will take a little bit longer because not only have you got to transfer the heat through the plug, you've also got to transfer the heat through the wire, and that silicone coating is absolutely wicking that heat away. So there we go, that's the positive in. We'll do the same with the negative. There we go. I'm just going to put a little bit more solder on each one of them now they're in. And we'll just let that cool down. So there we go. Hopefully it's cooled down enough. There we go. So we've got nice soldered joints there. They're not going anywhere. And then all we do just to tidy it up is just slip over a couple of bits of heat shrink tube. Same again. Just helps to protect the joint from corrosion. That's it. And then I like to use these little wire covers, which just slip over the top, and there we go. So there you go, got a nice clean either battery or ESC joint. Now, very important, if you're doing batteries, make sure you only do one wire at a time, because obviously if at any point you touch the two wires together, you're going to potentially damage the battery. So finally, let's just have a look at that, the use of the flux. What would you use that for? And we can have a quick go with it, and maybe have a go with the desoldering as well. But if you were making your own circuit boards, and what I've used this for in the past is, if you want to have, say you want to wire lots of LEDs onto the same power circuit, what you can do is cut a couple of strips of this, put a couple of power wires on one end, and then you can just, in every set of holes, just have a set of LEDs or an LED, and you're basically creating like a buzz bar, and it just saves you having lots and lots of wires all wrapped together. It's just a bit of a neater way of doing it, and obviously it helps distribute the power all the way along as well. So what we'll do, we'll have a go at this without using any flux, and then we'll have a go using some flux, and we'll just have a look at the difference, and then we'll have a go of desoldering with that solder wick. So I've just set this up just off of the workbench, because this is a metal workbench. This is actually my welding table that I designed, and it's very, very handy for welding, but it's not very good for soldering because it just sucks that heat away almost instantly. So first of all, what you need to do is get yourself some more solder. Again, clean the tip, tin it up a little bit, and then all we're going to do, we're just going to rub this along here, and it's basically making this a soldered buzz bar, and it does work. And what you can do is every set of LEDs or whatever you add to this, you can just add them because it's pre-soldered. And as you can see, you've got the joint down the middle, so you're not going to contaminate those joints, i.e. you're not going to create a short. So what we've done there, we've just soldered those up, and then what you could do is, I don't think these come tin, so I'll just tin it. Then what you can do is just get your LED wire and just go along, and then you can just add them. You can use the holes if you want to, but you can just add them like that. Just keep adding them along, and it works really well. So what we do, we just take them off, and then what I'll do, I'll just demonstrate this solder wick. So I'm just going to load this up a bit with solder. This is not what you want. So as you can see now, that would create a short. Hopefully you can see that. Now, one thing I'll say with the solder wick is not only does it wick the solder, it wicks the heat. So be very prepared to get burnt fingers or hold it with something. So all we do, we just introduce that solder wick in, and we rub it backwards and forwards, and as you can see, the solder wick is soaking up all that solder, as the name suggests, and we just rub it on there like that, and as you can see, that big blob of solder's gone. Now if you want to facilitate that a little bit more, we'll just put a little bit of this flux on here. Be careful because it does shoot out quite quick if you're not careful. So we just add a bit of flux, and then we're just using the side of the iron to introduce a bit more heat a bit quicker, and then that's wicking that away nicely. And then hopefully what you'll see is, get that smoke out of the way, and yes, the smoke that comes off is not good for you. So I'm in a well ventilated workshop, and although I've turned it off for the sake of the video, I have got an extractor fan in here that will get rid of all that nasty smoke in a moment. So there we go. You can see I loaded it up to do the soldered joints first, then I really put loads and loads of solder in there to get that solder wick in, and you can see how contaminated with solder that solder wick is now. Hopefully that'll, there we go, and then we wicked it all away, and we've gone back to a nice clean bare circuit board. So there we go, some simple soldering tips and tricks for you, and hopefully that's going to make it a bit easier for you to apply that in your hobby. So 3 of the jobs that we did, all great examples of things that we're going to use in the hobby. We desoldered, tinned and resoldered the motor. This is probably going to be one of the more common ones, and that's exactly the same with any size motor really. We did that battery connector or ESC connector, and again, that's a heavy gauge wire, so it's going to take a little bit longer to solder, but as you could see, what did that take? It took less than a minute. You know, it really shouldn't take that long at all. If it's taking a long time, you're doing something wrong, or there's something wrong with your equipment. And then lastly, we did that repair on the servo wire. And if you look at the video that I'll link at the end of this one, where I repaired that servo and the all-in-one fusion, this came into play in that, most definitely. So probably one of the more intricate jobs that you'll do. 3 wires at the same time can be a little bit fiddly, but just take your time. There's no rush, and you know, you can get a nice clean joint like that. So out of the tools, they were both really good. I wouldn't knock this one at all. The only thing I would say is that the V grooves in there were a little bit restrictive. Obviously, the further you push it down, the more awkward it makes it to get to. So out of the tools, my favourite was this clamp type. And like I said, it's really simple. It's just a really easy 3D print. I'm sure most of you have got 3D printers or know somebody that has one. And then just a couple of elastic bands to suit the clamping of your nature. I mean, I've got one elastic band on there that's doubled over, and to me that holds them wires perfectly. And it's just that extra pair of hands, isn't it, that you're not going to burn them. You know, we've all ended up with burnt fingertips and things like that, haven't we, when soldering? So, you know, if you can get something like that, and again, if you damage it, just print another one. You know, it's probably cost, what, 50 pence in filament, maybe that. But really handy tool. So thanks whoever come up with this idea, thank you very much. It's helped me no end already, and I've only used it 2 or 3 times, but I definitely know that's going to get used a lot. And as I said previously, don't overlook the humble clothes peg. You know, make sure it's a wooden one. Plastic one, if you melt it, it's going to give off gases and not going to be good for you anyway. But I've used clothes pegs for doing this for years and years, and you know, it's always helped me out. I've always thought sometimes I could do with a little bit more clamping force, but you know, there's other ways to clamp them. I could use my clamps, I could put a weight on it. Quite often put the soldering iron on the side, so I'm not holding the soldering iron, and I'll hold the job and the cable. The only downside with that is that's where you often end up with burnt fingers. So excellent tools. Sadly, I think this one's going to be going in the bin. But yeah, definitely this one's going to be doing a lot of work in this workshop. So that's it. I hope it's helped. If you need any help with advice on what to buy, give me a shout. At the end of the day, if you buy a soldering iron that is capable of doing between 350 and 450 degrees, it should be adequate. I'm not one for keep adjusting things all the time. If it works for me, then I'll leave it. I think that iron that I've got is 450 degrees. But like I said, it is auto sensing, so it does detect, like when you use those bigger cables, as soon as you touch it on there, it absolutely laps the heat out of the soldering tip, and then the soldering iron will detect that and it will build up the temperature again. So and go for the fluxed solder as well, low melt solder, absolutely brilliant stuff. Pay a little bit more for it quite often, but I've got a couple of rolls up there. If I've had them, I've probably had them over 5 years, and I do a lot of soldering, so you know, it goes a long way. So that's it. I hope it's helped. I hope you've enjoyed the video. Please drop a like and a subscribe, because it's really helping me. Channel's starting to grow a little bit now, and I'm getting noticed a little bit, so you should start to see some more interesting videos coming up. If you've got any ideas for videos as well, let me know. And we're coming up to Christmas, so hopefully we've got some goodies coming in the post. I'll catch you soon, guys. I'll look forward to seeing you in the next one.